See, dear student, we are discussing today potential due to dipole. In last topic, we have discussed potential due to single point charge V equal to 1 upon 4 pi F0 Q by R. Means V proportional to Q and inversely proportional to R. That is the potential due to single point charge. Again remember that what is the potential? Potential means work is required to be done in bringing a unit test charge from infinite to a given point against electric field is known as potential at that point. Now see, we start the topic. Dipole. As you know, what is dipole? Two equal and opposite charge. Two equal and opposite charge separated by a finite distance, then it is known as electric dipole. Here we have taken two charges plus Q and minus Q. Separation between them is 2A. Then it is electric dipole. Now we have selected midpoint at the origin and dipole moment P Q into 2A directed from negative Q to positive Q, minus Q to plus Q. It is a vector directed minus Q to plus Q given by Q into 2A. Now suppose we have taken a point P where field is to be found. As we know, two charges are there. Due to dipole, field is produced. And at that point we have to find or calculate potential. Means work required to be done in bringing a unit test charge from infinite to that point against electric field is nothing but potential of that point. Here work depends upon electric field. Here field is due to two charges plus Q and minus Q. So we have applied principle of superposition. Similarly, here also we can apply superposition principle. Now see, the point P is the point P where field is to be found. The position vector of which is R. And R1 and R2 are the distances of that point from plus Q and minus Q respectively. R1 and R2 are distances, but R is the position vector. And angle of that position vector with dipole moment is theta. Now, at point P, potential due to plus Q and potential due to minus Q is suppose V plus and V minus. V plus is the potential at point P due to plus Q and V minus is the potential at point P due to minus Q. According to principle of superposition, we can write V equal to V plus V minus. V plus according to point charge, V plus is nothing but 1 upon 4 pi epsilon 0 Q by R1 plus V minus means minus 1 upon 4 pi epsilon 0 Q by R2. So 1 upon 4 pi epsilon 0 common, Q by R1 minus Q by R2. Also we can write it this way, Q upon 4 pi epsilon 0 1 upon R1 minus 1 upon R2. Equation 1. Equation 1 is nothing but principle of superposition for potential due to plus Q and minus Q. Now see, if value of 1 upon R1 and 1 upon R2 is known, then by substituting this we get the answer. Main point is term 1 upon R1 minus 1 upon R2. Now using geometry of the figure, if you know cosine formula, then R1 square is R square plus A square minus 2AR cos theta. This side only is A. So we can write R1 square, this square, equal to R square plus A square, means addition of square of two sides, then R square plus A square, and minus 2AR cos theta. R1 square equal to R square plus A square minus 2AR cos theta. But here we have taken concept or condition R is greater than A. Then means point is very far away compared to size of the dipole. Means we can write R square common in the bracket 1 plus A square by R square minus 2AR cos theta by R square, means only R. R square common, 1 plus A square by R square minus 2AR cos theta by R square, means 2A cos theta upon R. Similarly, R2 square for second triangle OP and minus Q. Then again R square plus A square plus this angle is pi minus theta. So again we can write 2 minus 2AR cos pi minus theta. But cos pi minus theta is minus cos theta. So here it will be 2AR cos theta. Here minus sign, but here it is pi minus theta. So final answer is plus 2AR cos theta. Again as above, R square 1 plus A square by R square minus 2A cos theta by R, plus equation 2 and 3. Now r is greater than a, so a square by r square will be very small, so it can be neglected. So we can write r1 square equal to r square 1 minus 2a cos theta upon r. And r2 square equal to r square 1 plus 2a cos theta by r. Equation 4. Then we require 1 upon r1 and 1 upon r2. r1 square is there. Now taking reciprocal and square root. Reciprocal means 1 upon r1 square equal to 1 upon r1 r square in the bracket 1 minus 2a cos theta upon r. Simply we can write 1 upon r1 reciprocal and then square root. It is 1 upon r in the bracket 1 minus 2a cos theta upon r raised to minus 1 by 2. Reciprocal and square root. Simply we can say 1 upon r1 square equal to 1 upon r square in the bracket 1 minus 2a cos theta by r. We can write it this way: 1 minus 2a cos theta by r raised to minus 1 by 2. And similarly for 1 upon r2, 1 upon r 1 plus 2a cos theta by r raised to minus 1 by 2. Now using binomial theorem and neglecting higher order terms, as we have taken r is greater than a. For this condition, using binomial theorems and higher order terms can be neglected. So equation 5 can be represented as 1 upon r1 equal to 1 upon r in the bracket 1 power minus 2a cos theta by r multiplied by minus 1 by 2. So 1 plus a cos theta by r, and 1 upon r2 is 1 upon r 1 minus a cos theta by r. Now it is 1 upon r1, 1 upon r2. Required terms in equation 6. Now putting the value of equation 6 in equation 1, this is the required expression. So we can write V equal to Q upon 4 pi epsilon 0 1 upon r1 minus 1 upon r2. In both the terms 1 upon r is common, so 1 upon r common. Remaining terms 1 plus a cos theta upon r minus 1 plus a cos theta upon r. So this will be cancelled. A cos theta upon r plus a cos theta upon r means 2 times q upon 4 pi epsilon 0 2a cos theta upon r and r, so r square. So simple formula is this one. V equal to q into 2a cos theta upon 4 pi epsilon 0 by r square. See, this is general form, but remember this point. This is not exact answer, but it is approximation. So we can say right in this way, this is approximation up to find it. Only correct when the point is very far away. Now, definition. P equal to Q into 2A. So we can write this as P. So V equal to P cos theta upon 4 pi epsilon 0 r square. Means potential due to dipole depends upon P and also angle theta between r position vector and dipole moment. If we are taking unit vector in the r vector, so we can write P cos theta as vector P dot r cap. P cos theta can be written as vector P dot r cap. R cap the unit vector in the direction of r upon 4 pi epsilon 0 r square. That is required equation. This equation is not exactly correct, but approximation. Means for only large distance. If this is a point dipole, means charges are very close, then it is point dipole, it is exactly correct. Approximation for common dipole, but if point dipole, then exactly correct. Now we are discussing two cases. You know, this is the axis of the dipole and this is the equator of the dipole. Now, if the point is lying on the equator, then theta may be 0, or on the side, then maybe pi. Means for axis, theta is 0 or pi. If on the positive side of the positive charge, then theta will be 0. In on negative side, then theta is pi. Then V can be written as plus minus P upon 4 pi epsilon 0 r square. P cos theta 1. If 0, then plus 1. If pi, then minus 1. Means plus minus P upon 4 pi epsilon 0 r square. This is for the equator. Also, you can understand this one. Suppose point is lying very close to the or on positive charge, then it is near to the positive charge and far away from the negative charge. So positive potential is somewhat more compared to negative. So algebraic sum gives positive. If lying on negative side, away from the positive, closer to the negative, so negative will be more, so value will be negative. Now if lying on the equator, then theta is pi by 2. If point is lying on the equator, then theta is pi by 2, then p cos pi by 2 means v will be 0. On axis, v equal to plus minus p upon 4 pi epsilon 0 r square, and v equal to 0 on equatorial plane or equator. So in this way, now see common difference. For a single point charge, v proportional to 1 upon r, while for the dipole proportional to 1 upon r square. In that case, q, here it is proportional to p. This is the main difference between single point charge and dipole, potential due to dipole and single point charge. Now, next topic, we are discussing potential due to system of charge. System of charges. Now see, as we have discussed in previous topic, if single charge, then potential is given by V equal to 1 upon 4 pi epsilon 0 Q by R. If two or more charges are there in the system, then net potential can be obtained using principle of superposition. Now here simple case is there. Suppose we have taken point P and the charges, suppose Q1, Q2, Q3, Q4 and Q5. We have taken system of charges containing 5 charges, Q1, Q2, Q3, Q4 and Q5. Then we can say P is the point where potential is to be found. Then Q1 and P, distance between them is R1P. Here R2P, sorry, R5P, R4P, R3P, R2P. Their distance. Potential to first charge Q1, as you know. Suppose we are taking V1, V2 first charge. Then 1 upon 4 pi epsilon 0 Q1 by R1P. According to single point charge, potential at point P due to first charge, suppose V1, then V1 is 1 upon 4 pi epsilon 0 Q1 upon RP. Similarly, you can write for V2, then 1 upon 4 pi epsilon 0 Q2 upon R2P. V3 equal to 1 upon 4 pi epsilon 0 Q3 upon R3P, and so on. Each of 5, suppose so many charges are there, then we can write in this way. Now, according to principle of superposition, V equal to V1 plus V2 plus V3 up to what you required. Then we have to add these all terms. So we can write 1 upon 4 pi epsilon 0 Q1 upon R1P plus Q2 upon R2P plus Q3 upon R3P, and so on. So simply we can write V is 1 upon 4 pi epsilon 0 sigma of Qi upon RIP from 1 to n. In this way we can find total potential due to system of charges. See, we have discussed two topics. First, dipole potential, and second, due to system of charges. In both we have applied principle of superposition. Now, next topic next time.